Hi, my name is Julia, and today I'll be discussing the impact of Big Five personality characteristics on emotion recognition. The ability to recognize others' emotions is a fundamental source of social information. However, facial affect is very complex and can be interpreted differently by different people. What emotion do you see here? Both of these expressions are somewhat ambiguous, yet categorized differently by different people. Our study examines how people's categorization of ambiguous facial affect is influenced by their personality. Previous studies have explored how personality traits influence how people perceive others' emotions. One of the most commonly used models of personality is the Big Five model. However, the literature regarding Big Five personality traits to emotion recognition is mixed. Neuroticism is a trait that is associated with increased negative affect. This trait has two competing hypotheses. One theory associates it with an increased ability to identify negative facial expressions because neurotic people tend to negatively skew experiences. Alternatively, neuroticism may be associated with a reduced ability to identify facial affect. This is based on the tendency neurotic individuals have to be emotionally avoidant. Some studies have found that openness, conscientiousness, and agreeableness are related to enhanced emotion perception. This may be due to increased observational skills. Highly open people are naturally curious, and highly conscientious people are attentive to their environments. Extroverts have two competing hypotheses as well. Highly extroverted people typically maintain positive social connections. Some studies predict increased tendencies to rate faces as happy based on the positive affect associated with extroverted people. Others predict more of a sensitivity to others' emotions due to an extrovert's tendency to take in information concerning the emotions of those around them. In this study, we hypothesized that neurotic individuals would show reduced thresholds in categorizing negative emotions. We remained agnostic about the influence of openness, conscientiousness, agreeableness, and extroversion. For this study, we recruited a sample of 21 undergraduate students between the ages of 18 and 22. Our sample was primarily Hispanic and Asian and had almost equal representation of males and females. Each participant completed an emotion identification task. In each trial, participants were briefly presented with a face stimuli, followed by a visual noise mask. They then chose whether the face was angry, happy, afraid, or sad. Prior to participating in the emotion identification task, participants completed the Big Five inventory, which measures their personality traits. The stimuli was developed for this task using images of 4 individuals, each expressing happiness, fear, and anger. We use these images to develop 15 morphs equally spaced along 2 emotional spectra, happiness to fear and happiness to anger. Images further to the left are made up of more happy than threat expressions. Selecting them as representing anger or fear would indicate you're seeing threat earlier or have a lower threat threshold. Thresholds were estimated by calculating the point of subjective equality through each participant's psychometric function. Each subject's threshold tells you at which facial expression that person's judgment switched from one emotion to another. Looking at the happy-fearful spectrum, you can see how the faces map onto the threshold diagram. Each number along the x-axis represents a morph along the spectrum. Where the threat threshold lies represents which face they began to switch interpretations. In this example, it is between the 7th and 8th morph where they began changing their judgments. Our analysis found a marginal effect of neuroticism on emotion recognition so that highly neurotic individuals were less sensitive to negative emotions than participants who had lower neuroticism scores. This means they had an increased threat threshold. In the diagrams, you see that the happy-angry thresholds are on the left and the happy-fear thresholds are marked on the right. The dotted line represents those high in neuroticism and the solid lines represent individuals with low neuroticism. In the first diagram, you can see that anger was detected between the 6th and 7th morph for individuals both low and high in neuroticism. The second graph shows that individuals low in neuroticism detect fear approximately 1 morph earlier than individuals high in neuroticism. In addition to measuring people's emotion identification ratings, we also measured how quickly people made those ratings. An increase in reaction time might indicate that people are more sensitive to an emotion or more confident about their decision. There was a marginal effect of neuroticism on reaction time. Looking at the diagram, you can see that individuals low in neuroticism, the dotted lines, respond faster than individuals high in neuroticism, the solid lines. This was true for both angry and fear morphs. There was a significant effect for both openness and extroversion on reaction time. Anger morphs and fear morphs were identified faster in individuals with low levels of openness and extroversion compared to those with high levels of the traits. Low levels of the Big Five factors, neuroticism, openness, and extroversion, led to reduced reaction times. We theorized the effect of openness and extroversion may be linked to a tendency for those high in extroversion and openness to judge others more slowly than others low in those traits. Contrary to our hypothesis, individuals high in neuroticism are less sensitive to recognize negative emotions than people low in neuroticism. This may cause or be caused by a reduced inclination to take in environmental and emotional cues or a self-focused disposition. This state may lead to impoverished social connections due to a reduced ability to accurately identify negative emotions. We are planning on further exploring the implications of recognition capability and reaction times by measuring subjects' physiological and neural responses to these stimuli. I'd like to thank my graduate mentor, Dana Glenn, as well as Professor Peters and Professor Michalska for all their guidance, expertise, and insight. Thank you.